Hello, can everyone hear me clearly, even in the end? Okay, that's good. Mm, right now, let's start the session. And today is the mobile tutorial, and together with the 5G. So I myself, I'm from ONF. My name is Pingping Lin, and I'm the COMAC technical lead. And together with our technical team, can you stand up and let everybody know? So later on in this morning for the COMAC session, our team will introduce and for the slides and also the hands-on. Yeah. Do you want to introduce yourself right now? Yeah. Oh, maybe later because okay, good.
Hi, my name is Hyun Sun Moon. I'm from ONF. I recently joined and I will run a hands-on session today.
Yeah, hi, I am Ujun Kim. Also, I'm working from ONF, and yeah, I also covered second session tutorial.
Hi everyone, my name is Do Young-mi and I'm intern in ONF and I also join next session presentation.
Yes, and we also have a colleague remotely joining us, and later on I will let himself to introduce himself. Before everything, I want to have a quick and brief introduction to the ONF, and this is very helpful for understanding our mobile project. What's the mobile project in ONF? So the ONF, the mission is to transform the operator networks. Why? The reason is very simple: to bring the capex and opex efficiencies, and also bring the innovative services together with the innovative revenues. How we do this? We work with the service providers closely and based on such technologies, the disaggregation, white box, open source, and the SDNFV cloudification. These technologies here. And we focus on the edge and access network. Here, I want to explain the ONF model, how things works. First, we work closely with the service provider. I think most of you may already know the service provider is our sponsor. So from the day one, we work with the service provider. So far, it's more than 7 years. And then for the use cases, it's all from the service provider. Several service providers will find some common use cases, and then together with the ONF, we will pursue them. And the most important thing here is after finding the use cases, the operators committed to deployment. Then it will go to the lab engineer staff at ONF. The next stage is the service chain companies will jump in and helping us. And this including enhance the software and also like integrating and deploying the supply chain companies. There will be several. Together with ONF, it will deploy to the service provider here. So it's like a loop. This is our model, how it works. This page, I will show the strategy of the reference design and the exemplar platform here. So the most important thing here we are open source. And the first action is operator agree on the exemplar platform, use the selected open source, and some are commercial. We also embrace the commercial components. Then we form the reference design here. The reference design is designed by the operators of ONF, the community together. And finally, because the operators are committed to deployment, so the reference design will directly become the gold standard of the RFP for the deployment. So here's the strategy, how things works. Let's quickly review what's the open source component so far in OS. ONF, and including ONOS, COMAC, Stratum. Okay, I don't pick it one by one. This is a list. And here, the reference design, you can see COMAC is one of the reference design already. And also, COMAC is also an exemplar platform already. So let's, after quickly review the ONF and the model, let's see what's the mobile project in ONF. Several years ago, we launched the code, an open source edge cloud platform based on open source, and the software-defined control network, and of course with the commodity service. Then, based on the code platform, we put the mobile ingredients, the mobile components on it. We call it M-code. Then, since this year, the February, we together with the community, we open source the OMAC, the 3GPP core, which is already open source on our GitHub. And the last here is the COMAC. The COMAC is also an open source platform. It's a converged platform. Today, this morning, we will focus on the COMAC. Later on, I will explain what's a COMAC, why we need a convergence. It's still active project, and it's a basic platform. It's a standard basic platform for the edge. The COMAC, like OMAC, all based on that platform. Like OMAC is just the 3GPP core. It's just a part of the platform. So code is the basic platform, still there, active. So the next one, let's take a look at the COMAC, the converged multi-access and core here. So what's the COMAC? The scope here is we want to develop a modular, cost-efficient platform together with the components with well-defined interfaces. This is the scope. Some key functions here included is the 3GPP cellular network, cellular core, and the converged user plan function, converged control plan function together with the applications. And of course, we have the controllers, SIM controllers for both the access and the core network. Here is the scope of the COMAC. So let's see the big picture of the COMAC. Why we need a multi-access and why we need convergence. So I think everybody are familiar with this picture here. Here is the cellular base station and the core network, and then here is the residential network. It can go to the home, the family home. It also can go to the enterprise network here, the fixed broadband fixed network. So at the central office, both is running the core network of the mobile and the core network of the broadband fixed network, like BNG is here, also including the telecom apps. And also on the public internet, there's the OTT application here. So this is the current status for today. So our first action item will start from the central office. We will change it to a telco cloud. So you can see after changing to the telco cloud, we will use the disaggregation. First, we virtualize all the components, including the mobile core network and the BNG. And further, we disaggregate the control plan and the user plan, also running on the telco cloud here. So the next step is extension the telco cloud. So the telco cloud, you can treat it as a central or remote cloud. Normally, like when you drive on the highway or you walk in the community, you can see the base station everywhere, but the central office is not as many as the base station. So for most of the case, the central office is a little bit far away from the end user. So the next action will extend the tackle cloud here to the edge. Then the edge cloud is more near the end users. And for the edge cloud, we will do the several actions here. The first, we use the splitted in node B. The CU will running on the edge. We leave the RU, the data unit, still near the user. This is the first item. And then we move the 3GPP call to the edge cloud. Here, especially the data plane, like the gateways, the S gateway, packet gateway. Once we move the gateway there, then we can bring the end applications also near the edge. This is the benefit. So similarly, like for the broadband fixed network, we also put the BNG, move it to the edge cloud here. So then, because both the gateway, whether it's mobile or it's the fixed network, since the gateway are moved to the edge cloud, so we can also move the applications from the far away in the central office, move to the edge, more near the users. So the direct benefit is we have a lot in the world. We have a lot to need a low latency. So this is a directly benefit to the low latency applications. Of course, for the public, the OTT applications also can move to the edge. Here is our big picture. And at the end, to better program operate the network, we use the async control here at the edge also. For example, for the fabric here, we use the ONF together inside the tree layers. We use the segment routing and all-nodes to control the fabric. And we use the all-nodes together with the RAN slicing to control the base station for the radio slicing. And here is the async control here. Okay. Let's see the COMAC failures, components, and evolution here. Luckily, in the recent several years, there are several cutting-edge technologies became more and more mature, which the COMAC needs to depend on, like the virtualization, the function disaggregation, and also the control plane, user plane separation here. And the last one is cloudification at the edge. So here is the 4 pillars the COMAC need to depend on. So we talk about the converge. What we need to converge? We talked about the cellular network. We talked about the broadband fixed network. Then what need to converge? So here is the 3 pieces we need to converge. First is the 3GPP call. Then it's the 3GPP RAN control unit and the CBNG here. Here is for the for the fixed network. You may notice the RAN, the CU here is only the control unit. For the call, we already split it into control plane and data plane. And for the BNG, same control plane and the data plane separated. So we will put all the control planes together and also put the data planes together. They are a little bit different, but still have some common functions. Whether it's mobile or fixed network, like for the user plan, they need the authentication, billing, this kind of common features. So, and the data plan is similar. So the final result, we will converge the control plan and the data plan. This is the what's the convergence. So here's sorry, I didn't hear. Can you say that again here? Yes. Yes. Oh, okay. We have several split options together with the base station company, like for example KVM and like Accelerant. Indeed, they investigate in different cases, they use different layer of separation. For example, even in KVM itself, it has the layer 3 and layer 4 separation, layer 2 and layer 3 separation. If you split in different layers, there will be different result. So for here, the first stage here, we work together with accelerant for both of the accelerant and the KVM. So far, we only move the CO to the cloud here. So it's also depending we have all different options. Depends on the deployment, the specific deployment case, we can separate in different layers. Yeah. Okay, no problem. And the next, yeah. The previous one. Okay. Yes. Yes. For example, automatic driving, the low latency application. Of course, we need the application more near the user is better. A lot of use cases, like the VR, need high bandwidth and low latency together. There are a lot of such applications, like a new fitness use case, need this feature. Yeah, I can give you an example. If you just use the 4G network from your phone to the base station to then from the base station is run, then go to the transport network, the carrier transport network, then go to the central office. Normally the central, the call network, in whether in China or in US, maybe there are only less than 100. So it's the central office, which is running the 3GPP call network, is very far away from the user. So the latency is most of the time is more than 100 milliseconds. For example, the self-automatic driving cars, it needed around 20 milliseconds. So this will be the current 4G network. We couldn't meet this application's requirement. So there's a bunch of such low latency requirement applications. If we move the call more near, which means especially the gateway, we move the gateway, the SKV or packet gateway, we move it more near the user. Then after the SGI interface, then we can put the applications there. Because in the mobile network, the user must go to the gateway, the mobile call network, then go to the OTT applications, then or like a YouTube or something. Okay. Mm-hmm.
Is mobile and he's jumping from one cell to another. Wouldn't the sync time be even worse than having the data access from before?
Okay. For this question, to be honest, we are in discussion. I don't have a direct answer for that. Welcome, we discuss further, because right now I have no direct answer to that. Okay. Yeah. This is I visit a few self-auto drive companies. Some of them, their policy is just use the V2X, put all the decisions into the car itself. And some of the automatic drive companies, they put some decisions inside the car itself, and for collecting the data, and they still pushing it to the cloud, their private cloud, like this. And the 20 milliseconds is one company told me. I asked the other company, they may tell you below 80 milliseconds they also can accept. This is just a general idea I give you. No. I just talked to them directly. They give me this number. Yeah. Hmm? can do both. Right, can do both. The architecture inside, you can see, is the CAP, control plane and the user plane separated. Yes, I understand. So for pure 5G, we still miss a lot of features. So right now, like maybe 7%, 70% more like 4G. Only a few the architecture, some of the ideas we have the 5G here. And for all of us, we meet a lot of functions inside the 5G here. Vikram want to answer? Yeah.
Going to be available in phase 2 of release testing, which is going to come in December. So then once we have clarity, we can map it to the government. Right. Yeah. Right. Yeah. Yeah. Yeah, it's not one-to-one mapping. I'm just saying equivalent of curves. If I see in 5G can be the slicing part, which will be slicing overall from including AMF to SMF and everything, complete slice. But that part is not very clear yet. I mean, spec is not out for the slicing part. EPC with cups. Basically for this use case, EPC with the cups. Right. Not as of now. That's in transition, as I said. We'll present on that tomorrow. But right now it's on release 13 with cups. The use case is with the cups.
Yeah. And for the 5G, of course, for example, in China, the service provider already deployed it. And when we visit each country, when the OF people go to visit each country, we always get the question, when you start the 5G, we can work together. So we have a OMAC weekly meeting, and we're also discussing what we missed compared with the 5G here. And later on, I will show how to join the weekly meeting if you are interested, and you can ask questions or contribute to the weekly meeting there. Okay. That's not the case here. Like you think this like nobody use 4G? Of course, there are a lot. For example. Yeah, let me give you a use case here, okay? Yes, maybe a lot of people also have this idea, like everybody are going to 5G and in testing stage while you still work on the 4G EPC here. So this is a very common question here. Like the 4G, yeah, it's mature. It's for the mobile users, right? Each service provider operates a very mature 4G network for mobile users. But you think about the LT. Like for example, our Sprint, the service provider, they use some of the components from the OMAC, especially the data plan, to use for the LTE use cases. There's still a lot of use cases beyond not just the mobile phone. There's still a lot of use cases we still need this technology. This is a And yes, also between the transaction from the 4G to 5G, there's still several years. And during this transaction, we still can use it. And a lot of special use cases, we also use this EPC here. And for example, if I want to explain more here, because for example, the static LT, we don't like the static, the current EPC, if you purchase from the vendors, it's an entire EPC for the mobile user. It's including all the functions. If you just want to provide the LTE or 4G network to the static IoT, these use cases, like static IoT, we don't need mobility, so we don't need the roaming function. If it's a private network, then we also don't need the billing system. We just want a high performance, but we need to connect a lot of devices in my private network, but a very simplified mobile call here. So if you use a COMAC, you can achieve this kind of target. Okay, which one? Last picture here. Yeah. The combination means here, today we already achieved coexistence. On the COMAC platform, we run both the residential edge and the edge cloud and the cellular mobile edge cloud here. So here today we achieved the coexistence. Like you run all the functions, virtual functions together on the edge cloud and give both the broadband access and the mobile access. And in the future here, right now it's just coexistence. So the long-term goal here is since both of the fixed and the mobile, they separated between the control plane and data plane, we will further and converge the control plane and the data plane together. This is the long-term plan.
So, for example, on the user plan side, how would you see the convergence? Are you doing it after the UPF, or are you doing it, for example, right between the CU and the UPF?
For like how to converge it, like via the mobile network data plan with terminal inside.
Protocol stack.
Yeah, understand. So for this one, we are still designing it. I understand your question. In cellular network, there's terminal inside. For the normal brand, the fixed network, there's no terminal. The billing system charge the all little bit different. But if you think in another perspective, for the service provider, let's take AT&T for example. They provide both the mobile network and the fixed network. For fixed broadband network, for these two networks, each network they have their own billing system, right? So it's different. If we run everything at the edge, we can merge some of the functions also together, not to use two setup systems. One is dedicated for mobile and one is dedicated for broadband.
But they do have two billing systems because they charge me twice anyway, right? So how would you converge those together? Well, it's really two different accounts with different authentication, different kind of a right to access certain things. For example, are you going to converge subscribers in such a way that the mobile subscriber and the broadband subscriber becomes one?
Yes. I have some answer. I myself also have a lot of questions here. Yes, for this conversion. And I think for I understand your point here. And I think for the very good answer, like 1, 2, 3, 4, answer your give a list why we converge, what's the benefit, how to do it. I think we have a team, the designing team in OF. I think I will later on get the good answer for you. Right now I can't answer it directly very well for this question. Yeah. Our network slicing is from the RAN to the SGI interface for the mobile. Yeah, we have different slicing networks. Yes. We also have the demo tomorrow, lunch and dinner. We will show the end to end. Okay, let's see the evolution. I only have two slides left. So the evolution here is in this February we released the OMAC This is together with the community, with the several companies, and And then, as right now, we are at the stage 2 here, the multi-access coexistence. For the COMAC here, and it's still not 100% production ready. For the data plan, we already have 2 users. The T-Mobile Poland and the Sprint are already using it and deployed in the T-Mobile Poland already deployed in the production network. For the control plan, the MME is not production ready, so we will try our best to make it production ready at the end of this year. And then the next step is so the question you to ask it is our next step is the user plan convergence, and then the control plan convergence. This is our next step, so that's why I couldn't give you a good answer today. And finally, we will achieve the COMAC, the real COMAC. Okay, the last page here, I like to share the EP release 1.0. Since the day one, the ONF people together with the community, we went a lot of conferences, like the MWC Barcelona from 2017 to 19, and the MWC American ONF Connect called build a lot of events. But in the past few years, we only showed demos with some cutting edge technologies. But it's time to change from just demos to the real field trial and the production network. So right now, the COMAC is graduating from just demos to the real world. And the first release of the COMAC is next Friday, September 20. And why we say the COMAC is almost production ready? Because in the past 6 months, a lot of things happened. First, you may already knew this graph here, and this is the SIBA part. Some components of the SIBA part. The COMAC also leverages the latest SIBA platform, including the Prometheus Grafana, the NAM, the ONUS, together with the Fabric applications and the Kubernetes. So this is already production ready. So we based on this platform, then we add the OMAC here, and further we add the mobile subscriber state monitoring here. For the first release, we will including all the components here. Then in the future, not after the first release, we will further integrate the run application, the SD run here. The last thing I want to say is for the SD-WAN and the multi-access edge cloud here, the China Unicom already planted to use for field trial. And at the end of this month, we will go there and had a first discussion with them about how to deploy and how to the field trial there, and also discuss the supply chain, this kind of issues there. Okay. If you have further questions, you can contact me. Also, you can contact us because this is all the slides here. I just represent for him. Okay, that's all for the first session.